All right, number 10 asks us to determine whether the equation has a graph that is symmetric with respect to the y-axis, x-axis, the origin, or none of these. And we've been given the equation y equals 7x to the fifth plus 7x cubed. And so what we're going to do is we're going to take this equation that they've given us and perform three separate tests to test for symmetry. We're going to test for x-axis symmetry, y-axis symmetry, and origin symmetry. And each of those tests is listed here to the right. And these two charts come directly from your textbook, pages 245 and 246. And so let's go ahead and test for x-axis symmetry. And we can see over here to the right that when we test for x-axis symmetry, the graph of an equation is symmetric with respect to the x-axis if the replacement of y with negative y results in an equivalent equation. And all that means is that we're going to take what we were originally given. So, and let me go ahead and label this. So we're doing x-axis symmetry. So that's what we're testing for here. And all we're going to do is take the original equation. So in this case, y equals 7x to the fifth plus 7x cubed. And our test here tells us to take the y that was originally in the equation and swap it out for a negative y. So let's take out this positive y, and instead we're going to input a negative y and see what happens. Do we get back to the original equation when we clean this up? Well, there's nothing outside the set of parentheses to distribute that will make the negative y change its sign. So we can go ahead and just drop those parentheses. So we have negative y equals 7x to the fifth plus 7x cubed. And because our original equation had a positive y, let's go ahead and make this y positive. And we can do that by multiplying this whole equation by negative 1. And when we do that, we'll end up with positive y equals, and then negative 1 times positive 7x to the fifth gives us negative 7x to the fifth, and negative 1 times positive 7x cubed gives us negative 7x cubed. And so now we can't go any further with this equation. We've simplified it, we've cleaned it up as much as we can. So what we want to ask ourselves is the original equation that we started with and what we ended up with after we substituted the positive y for negative y, are these two equations the same? Well, we can clearly see they're not the same, and so this particular graph, this equation, does not have x-axis symmetry. If it did have x-axis symmetry, when we replaced y with negative y and cleaned it up, we would have ended back with the same exact equation that we started with. But that's not what happened here. So this graph is not symmetric with respect to the x-axis. All right, I'm going to go ahead and clean, or rather delete all this. So if you need to copy that down, go ahead and pause, or we rewind. And now we'll take a look at x-axis, or y-axis symmetry rather. So y-axis symmetry, that's what we're going to test. And if you read over here to the right, the graph of an equation is symmetric with respect to the y-axis if the replacement of x with negative x results in an equivalent equation. So this time we're going to take the x that was originally in the equation and swap it out. So we have y equals 7, and again we're taking out the original x and swapping it for a negative x to the fifth, plus 7, taking out the x that was originally in our equation, swapping it out for a negative x cubed. And let's go ahead and clean this up and see what we get. So we have y equals 7, and then a negative number to an odd exponent is still negative. So we have negative x to the fifth plus 7, and again a negative number, negative x, a negative number to an odd exponent is still negative. And if we clean this up for the final time, let's go ahead, we'll distribute that 7 through. So we have positive 7 times negative x to the fifth gives us negative 7x to the fifth. Again, we'll distribute. Positive 7 times negative x cubed gives us negative 7x cubed. And so now that we've cleaned up our equation as much as we can't go any further here. we want to ask ourselves, is the original equation that we started with the same as the equation that we ended up with? And again, we can clearly see it's not. We started with y equals positive 7x to the fifth plus 7x cubed. We ended up with y equals negative 7x to the fifth minus 7x cubed. So we've got some sign changes. These are not the same. These are not equivalent equations. And so we can say that this is also a graph that is not symmetric with respect to the y-axis. All right, let's get rid of this and test for origin symmetry, our final test. So origin symmetry. And we can see here, if we read, the graph of an equation is symmetric with respect to the origin if the replacement of both x with negative x and y with negative y at the same time results in an equivalent equation. So now we're going to swap out x and y at the same time. All right, so again, swap out y with negative y equals 7. Swap out x with negative x to the fifth plus 7. Swap out that x with a negative x cubed. And let's clean this up and see what happens. Again, there's nothing out here to the left of this set of parentheses to distribute that will change the sign of this y, so it will go ahead and just stay negative y. We can drop those parentheses. Equals 7, and we know now that a negative number to an odd exponent remains negative. Again, a negative number to an odd exponent remains negative. And so we can clean this up again by distributing these 7s through their respective sets of parentheses. So we have 7 times negative x to the fifth is negative 7x to the fifth. Positive 7 times negative x cubed is negative 7x cubed. And let's go ahead and multiply this whole equation by negative 1. And when we do that, negative 1 times negative y is a positive y. Let me bring that up a little so we have some more room. All right, so negative 1 times negative y is positive y. Negative 1 times negative 7x to the fifth, positive 7x to the fifth. And finally, negative 1 times negative 7x cubed, positive or plus 7x cubed. And now that we've cleaned this up as much as we can't go any further here. We'll take a look and ask ourselves, is the equation we started with the same as the equation we ended up with? And we can see that it is. We ended with y equals 7x to the fifth plus 7x cubed, which is exactly what we started with. And so we can say that, yes, the graph that they gave us, y equals 7x to the fifth plus 7x cubed, has origin symmetry. It is symmetrical with respect to the origin. It is not symmetrical with respect to the y-axis, nor is it symmetrical to the x-axis, but it is symmetrical with respect to the origin. All right? And go ahead, and it's a good idea to memorize these 3 tests because they will certainly come in handy. All right, that was number 10. Let's take a look at number 11. I'll see you there.